Hi friends, today we are going to discuss about reflection of waves. Reflection of waves occur when a wave hits a surface or boundary and bounces back into the same medium instead of passing through the boundary. The example for this is an echo. So when echo, what happens is that when waves hit on a surface, the sound waves get reflected back. So here in this diagram, the wave is hitting in a surface or a boundary, and if this wave is not entering into the second medium and it is reflecting back into the surface, this is called the reflection of waves. So if part of the wave is transmitted into the second medium, the wave is called refracted wave. Suppose if part of the wave is refracted or entering into the second medium, that wave is called refracted wave, and if the waves overlap, that is a complex case. So in reflected wave, it consists of incident as well as reflected wave, and it obeys the usual laws of reflection. This you have already studied in your lower classes. And the refracted wave consists of incident as well as the refracted wave, and this will obey the Snell's law of refraction. And this reflection of waves is of two types. First one is fixed end reflection and second one is free end reflection. Consider you are having a boundary or a rigid wall and it is fixed to a rope, and if a wave is generated in the rope and if one end is fixed, this fixed end is called fixed end reflection, and another one end will be free, and the process which is happening here, it is called free end reflection. So when the wave hits the boundary or the wall, it hits the wall, and after hitting the wall, the phase of the wave will get reversed. Okay, so the first kind, fixed end, so the waves which is reflecting back when it's hitting after the wall will have a phase change of pi. So the wave will differ by a phase change of 180 degrees after hitting a rigid wall. So another one type is free end, and if the wave reflects back without inversion. So in free end, while the wave returns back to the rigid wall, there will be no change in phase, and this is called free end. And the mathematical expression for the incident wave is given as yi x comma t is equal to a sin kx minus omega t. So if at the rigid fixed boundary, the reflected wave is given by, it will have a phase change of pi. So we can write it as yr x comma t is equal to a sin kx minus omega t. Since it is undergoing a phase change, we have to add pi here. So if you are adding pi here, the value will become minus a sin kx minus omega t. So from this equation, we can observe that the wave gets inverted. And in next case, an open boundary. In open boundary, at the free end, the reflected wave is given by yr of x comma t is equal to a sin kx minus omega t. Since it is not going any phase change, you have to add only 0 here. So you will get the same value in case of open boundary as a sin kx minus omega t. Thank you.